you may assume these equations of motion. So we're given a displacement equation for x, namely this, and one for y as well. Plus, yeah, good. So there's our horizontal vertical displacement. So far, so good. Okay. Now, the next question, it's a proof question, which is one of the annoying ones. You're looking like, there's no answer. Lazy textbook writers, okay? It says, show that the condition for the particles to collide is this. V1 sine theta 1 equals this. Okay, so that's what they want you to prove, that if the particles collide, this must be true. Okay, it must be true and no other exceptions. Okay, now, you think about it from this point of view, namely, this equation they want us to prove, it has sines in it, right? Seems to have not that much to do with this and more to do with this. So there's our first clue, that it's going to have something to do with this. But what does it mean for things to collide? For P1 and P2 to collide, really what you need is for the x-coordinates of one particle to match the x-coordinates of the other particle at the exact same time. And the same thing for the y-coordinates, right? Like, you've got to have them both together, okay? So if I take this x-coordinate, right? This is just a general one. So I'm going to think about the first particle, P1, which starts over here. P2 starts over here. Okay? Since this is general, I just want to make it concrete to this specific particle. So that doesn't require all that much change. Since it's the displacement, horizontal displacement of the first particle, I'll call it x1, right? That has an initial velocity of v1. And here, instead of putting t for time as in generally speaking, okay? Yeah, no, actually I'll leave it here and I'll make it more specific later on. That's what I get for thinking as I go. So there's my first particle. My second particle is going to look exactly the same, almost, right? Okay, now for a collision, what am I going to want? Well, at some time, and I'm going to call it capital T, okay, just to make it an actual constant. I just don't know what it is. These two should be equal to each other, yeah? Now, there's a problem here. This equation works if you consider the particles beginning from the origin, okay? Now, just looking at there, which would you call the origin? What place would you call the origin? You really can pick anywhere. Most people instinctively, they pick A as the origin, okay? Because that's what most of our questions look like. You start there, you project that way. Now, if that's the case, then this equation here is fine, okay? But this one is not, because the second particle obviously is not starting at the origin. That's my first problem. My second problem is, you look at this, x2 equals v2. This is going toward the right, isn't it? This is going to be positive, okay? So not only is it starting at the wrong place, it's going in the wrong direction. So how do I adjust this x2 equation so it actually reflects where the origin is? Well, I've got to adjust two things. Number one, I've got to adjust its direction, okay? So since it's firing in the opposite direction, I'm going to slap a minus on the front, okay? So now it's heading to the left. But secondly, I've got to adjust where it begins. Now, where does it begin? Well, if this is the origin, okay, then whatever that distance is, which I have no idea what it is, that's how far away it begins, okay? So sort of a conventional way to say the length of an interval is to name the interval and then slap a line over the top. Okay, so that just means distance. So that's the real x2. Okay? So therefore, at some point time, t, these two should be equal to each other, right? Namely, v1, capital T, because of the first angle, should be this. Capital T. Okay, now, this is one of the conditions for a collision to occur, okay? But the problem is, I don't know what this is. It sounds funny, but I actually know what V1, theta 1, V2, and theta 2 are. They're just not defined for me, but I know what they are, whereas A, B is actually indeterminate. So as a condition, for these two particles colliding, it's kind of not very useful to me. Like, I need to know what AB is before I can actually use that as a useful condition. So therefore, that's why this is going after these equations. Okay? So this is a little easier to deal with because even though they're starting at two different places horizontally, vertically, they're starting at the same place. Right? Does that make sense? They're both starting at y equals 0. So I actually can use this equation for both particles, and I don't have to adjust it in this way that I did before. Okay? So therefore, I can say for P1 and P2 to collide, now let's look at their y coordinates, right? Y1 will be minus half gt squared plus this part is just the angle and the speed of projection that are adjusted. And my other particle will have this one. As a 2. Okay? So just like before, here, okay, for a collision to occur, at some time t, they have to be equal to each other. Okay? So therefore, I really shouldn't have interleaved these, but anyway, you get the idea. Minus half gt squared, this is going to be y1, that's what I'm writing, plus v1t, capital T. That's the vertical position of my first particle. That should be equal to the other one. I'll do a bad job today. Okay, so that's how we arrive at this equation. Okay, we think about what does it mean for this to apply to our specific particles. Okay, and then I just equate them. That's what collision means. That's what intersection is. So you can see all I need to do, these two are going to cancel out with each other. And also this capital T, I can just divide through by it. It's some positive time, so it doesn't matter what it is. So therefore, that's how you get V1 sine theta 1. That's got to be equal to V2 sine theta 2. Okay, so you happy with that? I know it's a little awkward, but this is actually kind of that's what you're going to get in an exam. Like, here's a result. How can you prove it out of this given situation? Okay? And that's why it's just actually this is why you can only go for the y value and not the x value, because you don't know enough about the x value to say anything meaningful about it. Okay?